Hello children. Today we will be continuing the same chapter, force and pressure. Let us quickly recall what we have learned yesterday. Yesterday we had learned that gases exert pressure on the walls of the container because of continuous collisions of the molecules with the walls of the container. Gases exert pressure in all directions. Atmospheric pressure is defined as the force exerted per unit area on a surface by the weight of atmosphere above that surface. Atmospheric pressure decreases with altitude. Now, do you know how do we measure atmospheric pressure? The instrument used to measure atmospheric pressure is called the barometer. The simplest kind of barometer is Torricellian barometer, which is also called the mercury barometer. As you can see from the figure, it is an inverted glass tube standing in a bath of mercury. Air pressure pushes down on the surface of the mercury, making some rise up the tube. The greater the air pressure, the higher the mercury rises. You can read the pressure from the scale marked onto the glass. Barometers are basically of two types. The first one is the mercury barometer, which is also called the Fortin's barometer. And the second one is the dry barometer, which is also called the aneroid barometer. Let us first discuss about the Fortin's barometer. Fortin's barometer or the mercury barometer is a barometer which consists of three parts. The first one, the mercury cistern, the second, the glass barometer tube, and the third is the scale. The bottom of the mercury cistern is made of a washed leather bag, which is generally of a sheepskin. The mercury level can be changed by rotating an adjusting screw. An ivory pointer is put on the top of the mercury cistern, whose tip indicates the zero of the scale. When the level of the mercury touches the tip, the atmospheric pressure is read at the top of the mercury column. The precise height of the mercury column is measured with the vernier scale. Now, the second type of barometer, which is the aneroid barometer. It is also called the dry barometer because it does not have any kind of liquid in it. It is actually a portable and a compact barometer which is very easy to handle, but its accuracy is not as much as the mercury barometers have. So they are less accurate as compared to the mercury barometers. Now we come to the applications of atmospheric pressure. The presence of atmospheric pressure is utilized at a number of places. The first application is in case of a drinking straw. We normally use a straw at home. We use a straw to drink a juice or a cold drink. When we suck air at the upper end of the straw with our mouth, the pressure of the air inside the straw is reduced. But the pressure acting on the surface of the juice or the cold drink is equal to the atmospheric pressure. So, the liquid flows from a high pressure region to a low pressure region, that is, from the glass to inside the straw. The second is the syringe. When we dip a syringe in a liquid and pull its piston, the pressure inside the syringe gets reduced. The atmospheric pressure acting on the surface of the liquid is more in comparison to the air pressure in the syringe, and thus